Hello everyone, welcome to Young Innovators. In our last video, we had built few circuits on Tinkercad and understood their working. In this video, we will learn about an electric motor. When you switch on the switch for the fan, the blades starts to rotate. How does this happen? This task is done by an electric motor. By now, you would have understood the definition of an electric motor. In simple words, electric motor is defined as a device that converts electrical energy into mechanical energy. In case of our fans, when we switch on the button, electricity starts to flow, which is electrical energy, and the rotatory action of the blades is the mechanical energy or the mechanical work which is done. Motors are widely used in many applications like washing machines, grinders, mixers, etc. In recent years, motors also find a wide range of application in automobiles and electric cars. Let's explore on these motors and see its working principles, types and applications further. Coming to the types of motor, we majorly find two different types of motor. One, an AC motor, another, a DC motor. AC motors are those which are driven by the alternating current, and DC motors are the one which work on direct current. Let us look at the working of DC motors now. To understand this working principle, we need to understand about electromagnetism and motors construction. Electromagnetism is the interaction between current-carrying conductors and magnetic fields. The principle of electromagnets tell that whenever a current-carrying conductor is placed in magnetic fields, it experiences a force, and this force will always be in perpendicular direction to the magnetic field. The basic construction of DC motor has a stator, a rotor, a yoke, poles, armature windings, field windings, commutators and brushes. Let us look at each part in detail. A stator, as the name suggests, is the static unit containing the field windings. Rotor is a dynamic part of the DC motor that creates the mechanical rotations of the unit. A yoke is a magnetic frame made of cast iron or sometimes steel, which works as a protector. This protective cover keeps the inner parts of the motor safe and sound and also supports the armature. DC motor has magnetic poles that fit into the inner walls of the yoke with the help of screws to tighten them up. Made with copper wire, the field windings circle around the slots carried by the pole shoes. The field windings form an electromagnet. Another part of DC motor is armature winding. Armature winding is attached to the rotor and alters the magnetic field in the path that it rotates. Commutator is another DC motor part which is connected to the armature, enabling this switching of current. The commutator is designed to commute the supply current to the armature winding from the mains. The commutator passes through the brushes of the DC motor. The last item on the DC motor or the last part of the DC motor is brush, which are made of carbon or graphite structures. Brushes with the commutator are working as a bridge to connect the static electrical circuit to the rotor. Brushes are in contact with the commutator and relay the produced current to the commutator from an external circuit. The current then moves into the armature winding. Now let us look at the working principle or operating principle of a DC motor. The armature coils in DC motor consist of commutators and brushes. Now consider that an armature coil is placed between the magnetic fields as shown. When given a DC supply, the current starts flowing and develops its own field around the coil. The field that are produced by the coil and magnets interact with each other, resulting in developing a field across the conductor too. This tends to regain its original position. The field exerts the force at the ends of a conductor, which makes the coil to rotate, and the current flow to the armature through the north pole and come out through the south pole. The current also flows through brushes and the polarities change without changing the direction of the force acting on the conductor, making the rotor or the conducting wire rotate continuously without any barriers or breaks. Motors find a wide range of applications due to their specific advantages like size, rotations, etc. At home, we find motors in small tools, toys, kitchen appliances, washing machines, etc. We also find motors in conveyors, industries, and many other places. I hope you have understood the concept and working principle of motors and its types. Thank you for watching.